Hello, in this video I want to talk about finding the derivative, and I'm going to work up to some examples related to implicit differentiation. So let's start off with the first example here. We have find dy dx, or find y prime, and our first example says that y, it's a function of x, so y equals x cubed plus 7x. So this is just our regular old standard derivative. We're going to go through here. I'll take the derivative on the left-hand side. That's y prime, or I can use the notation dy dx equals the derivative of x cubed. That's our power rule. So we've got 3x squared plus, now we've got a constant, so that's plus 7 times the derivative of x, which is just 1. Okay, so that one wasn't too bad. Let's crank it up a notch. So now, in example 2, I want to find dy dx. I'm still after my derivative. But notice I have not written y as a function of x. And notice it's not even a function of x. If I were to plot this creature, this is a circle. X squared plus y squared is a circle with radius square root of 10. So this is not a function. It's not a function because it would fail the vertical line test. So to find the derivative, I mean, maybe I want to find, the tangent line over here or something. I want to find the equation of a tangent line, and to do that, I need to find the derivative. I need to find the slope at that little point. So I still might be interested in finding dy dx, but I don't have it written in this nice explicit function notation, so I can't just use my old tricks. I'm going to need to use implicit differentiation. We have y implicitly defined in terms of x. It's not an explicit function, so I need to use implicit differentiation. All right, so let's go through here. We're going to go term by term, and I'm going to start with the first one, and I'm going to take the derivative with respect to x. So I'm going to write this notation, the derivative with respect to x of what? Well, I need to do x squared. Next, I'm using my sum rule here. I can break this all apart. So I've got the derivative with respect to x of y squared equals, right-hand side, the derivative with respect to x of 10. All right, let's see what this gives us. So the derivative with respect to x of x squared is just 2x, and that's because of the power rule. The derivative with respect to x of y squared, I'm going to essentially need to use my chain rule here. If I asked you to find, find d dx of u squared, you would have told me back in our chain rule chapter that that's 2u times u prime because of the chain rule. That's kind of the same idea here. I'm going to say that the derivative of y squared is 2y times the derivative of y, the derivative of y with respect to x. Right-hand side, the derivative with respect to x of 10 is just 0 because 10 is a constant. Now, my goal is to solve for dy dx. So let's solve for dy dx. I want to solve for dy dx. It's attached here to the 2y via multiplication. So let's start off here by subtracting 2x from both sides. That's going to give me 2y times dy dx on the left-hand side. And on the right-hand side, I'm going to have negative 2x. Now, to undo the multiplication, I need to divide both sides by 2y. Goodbye, goodbye. Left-hand side, I'm very happy now because I have dy dx. That's what I wanted to find. And on the right-hand side, my 2's cancel, so I just have negative x over y. So I found my derivative. So that's quite nice. The last one I want to do is even more complicated, but it's the same techniques here. I have in example 3, x squared plus 2y equals x times y. Now again, I'm after dy dx. I don't have y written as a function of x. It's not like an explicit function over here like f of x equals, So I'm going to need to use techniques of implicit differentiation. Let me make a little bit of space for us. Okay, so let's go through. Same deal. I'm going to go through term by term. First term, I'm going to do the derivative with respect to x of x squared plus the derivative with respect to x of 2y equals the derivative with respect to x of x times y. Next, the derivative with respect to x of x squared is just 2x plus constant rule here. I've got 2 out in front. The derivative with respect to x of y is just 1 times dy dx equals. Over here, I'm going to need to use product rule. So I'm going to write it out in its gory details. I'm going to do the derivative of the first times the regular second. So I'm going to do the derivative with respect to x of the first factor times the regular second, which was just y, plus the derivative of the second factor times the regular first. And I'm just going to write that here. Derivative of first times regular second factor plus the derivative of the second times the regular first. Sometimes the book writes it in another order, but addition and multiplication are commutative. So I always remember it this way because it's more similar to the quotient rule, and I don't have to remember 2 different things. But either way, same answer. All right, let's keep going here. A little border for our work. We have on the left-hand side 2x. That didn't change. We have a 2 times dy dx. That did not change. On the right-hand side, I have d dx of x. So I have the derivative with respect to x of x. That's just 1 times a regular old y. There it is. Plus the derivative with respect to x of y is just 1 times dy dx times a regular old x. All right, this is looking good. We do need to solve for dy dx. So I need to get all of the terms with dy dx together. So I've got one here, and I've got another one over here. So I'm going to put all of the terms with dy dx over here on the right-hand side and everybody else over on the left. So to start with that, I'm going to subtract y from both sides. And I'm also going to subtract a 2 dy dx from both sides. Let's clean this up. On the left-hand side, I have a 2x minus y. Just make a little bit of space. All right, we're back in action. So we have a 2x minus y over here on the left-hand side. This other business, the 2 dy dx canceled. That was good. So our left-hand side is all done. Over on the right-hand side, y and the negative y, those canceled out. So that's not there. I just have the x times dy dx minus a 2 times a dy dx. This is looking better, but I still need to solve for dy dx equals some expression. So let's pull out a common factor here. And my common factor is going to be dy dx. Left-hand side did not change. right-hand side, common factor is dy dx. When I pull that out in front, I have left over an x minus 2. Solving for dy dx, well, I need to undo or unattach this multiplication, so it means I'm going to divide both sides by x minus 2. Divide. And now we're done, because over on the left-hand side, I have 2x minus y over x minus 2, and on the right-hand side, dy dx. So I've achieved my goal of solving for dy dx. But do notice how I kept everything lined up. I didn't scoot around and drive off the paper or anything. I kept everything lined up, my left-hand side, my right-hand side, because it's very easy to get off track with a problem like this. There's a lot of steps. So I do recommend that you write everything down and keep it all lined up as you work down the page.